Ah, the snooze button. That beautiful, beautiful 9-minute delay. For so many of us, it's just part of the morning ritual, right? It's totally non-negotiable. But what if that little tap, that tiny act of defiance against the day, is actually setting you up to fail? Well, today, we're going to find out. So let's just get right into it with the big question. Is this little button your friend? A gentle way to ease into the day? Or is it secretly a trap, making you groggier and your whole day feel off? The science here might actually surprise you. Okay, so if you're a snoozer, you are in very good company. One study found that a whopping 70.5% of people use the snooze button all the time. It's practically a universal habit. But, and this is a big but, just because everybody's doing it doesn't mean it's a good idea.
So why do we even do it? It's not just about squeezing in a few more Z's. The psychology is actually pretty interesting. The two main reasons are, 1, we're genuinely worried about not waking up on time, and 2, we want to feel secure that we will wake up eventually. It's like a safety net. The only problem is, that safety net might be tangled up in some consequences we didn't see coming.
To really understand what's wrong with our artificial alarms, we first have to appreciate the amazing natural alarm clock that we all have built right in. It's this incredible biological process called the cortisol awakening response. So the cortisol awakening response, or CAR for short, is basically your body's natural launch sequence. As soon as you wake up, your body unleashes this wave of cortisol. Now, I know cortisol gets a bad rap as the stress hormone, but in the morning, it's exactly what you want. It's the stuff that makes you feel alert and ready to go. And you can really see the effect right here. I mean, look at that jump. Within just 30 minutes of waking up, your cortisol levels can spike by an average of 15%. This isn't some gentle little nudge. It is a powerful biological signal that's screaming, hey, time to get going. So what's actually driving all this? Well, research points to the hippocampus, a really important part of your brain that handles memory and regulation. It's basically looking ahead, anticipating the demands of your day, and priming your whole system to be ready for whatever's coming. It's your brain's healthy, natural way of shifting gears from sleep to wake. Okay, so what happens when we hit that snooze button? Well, we're basically throwing a big wrench into that beautiful, elegant biological machine. And by interrupting this whole natural process, we end up paying a price. A price that scientists call sleep inertia and sleep fragmentation. We have all felt sleep inertia. You know what I'm talking about? That zombie-like feeling where your body is up, but your brain is definitely not online yet. It's totally normal for this to last a few minutes, but as you might have guessed, snoozing can make it so much worse. It's like a hangover, but from sleep. And this right here is the key. When you hit snooze, you're just confusing your brain. It starts the wake-up process, but then you drift back into this really light, junky sleep, only to be jolted awake again 9 minutes later. This horrible little cycle is what makes that sleep inertia drag on and on, hurting your performance for hours. But if you just get up with that first alarm, that grogginess clears out way faster. And the effects go way beyond just feeling tired. I mean, this research lays it out pretty clearly. That repeated cycle of waking up and dozing off, that sleep fragmentation, can have some serious consequences for your brain and your body. This is not a harmless little habit. All right, to really get why we feel so groggy, we've got to look at the chemistry. It really all comes down to this big battle happening inside your brain, starring a chemical called adenosine. Think of adenosine as your brain's own sleepiness timer. From the moment your eyes open in the morning, it starts to build up, second by second. And the more of it that accumulates, the stronger your sleep drive becomes, making you feel drowsy and just ready for bed. It's a really simple, beautiful cycle. Your brain uses energy all day, which creates adenosine. That adenosine builds up, making you sleepy. And then, while you're in a deep sleep, your brain's cleanup crew comes in and clears it all away so you can wake up feeling refreshed. Snoozing messes up that critical cleanup process, leaving you with all that leftover grogginess. So this is where our other favorite morning ritual comes in, coffee. But here's the thing, and it's a huge misconception. Caffeine doesn't actually give you energy. Not really. It's more like a master of disguise. It works by physically blocking the little receptors in your brain that detect adenosine, which basically tricks your brain into thinking it's not tired. And as sleep physician Dr. Avadavkar confirms here, caffeine's main gig is to act like a bouncer at a club, just blocking adenosine from getting in. But here's the catch. The adenosine doesn't go away. It's just hanging out outside, waiting. And when that caffeine finally wears off, all that built-up sleepiness can come rushing back in, all at once. So yeah, it's this complex battle between our natural sleep chemistry and our blaring morning alarms. It's really no wonder our struggle against the snooze button has led to some truly wild solutions over the years. I mean, people have invented alarm clocks that literally fly away, making you get out of bed to chase them down. There are robotic ones that run and hide under your furniture. We have gone to some pretty extreme lengths to just force ourselves to wake up. It kind of shows you just how hard this battle can be for so many of us. But look at this. This is data from an experiment with one of those intelligent alarms, this one called the bed runner. The results are absolutely dramatic. Compared to a normal alarm, snoozing dropped from 67% all the way down to just 8%. And oversleeping, it plummeted from 83% to under 17%. I mean, that is a massive, massive change. So why does this work so well? It's pretty simple, actually. These alarms force physical activity. By making you get up, move your body, and even think a little bit to find the alarm, you're literally kickstarting your body's own alert systems. It's a much more effective way to fight that sleep inertia than just mindlessly hitting a button. Which kind of brings us full circle, doesn't it? Our bodies have this amazing built-in system, that cortisol awakening response, designed to wake us up properly. And yet, we fight it every morning with the snooze button. These crazy alarm clocks, they only work because they force us to do something that's a little closer to a natural, active way of waking up. So maybe the real question isn't what new alarm clock you should buy, but are you ready to finally break the snooze habit and start listening to your own body's wake-up call?